So the purpose of this video is to use the molarity formula to solve for the amount of solvent. You know how strong or weak your solution is. You know how much stuff is dissolved in there, and you just want to know what's the volume. With numbers, it look kind of like this. I know my molarity is 3 molar NaCl. I know my solute is 27.14 grams, and I want to know what's my volume. You're going to need to remember the molarity pyramid or the molarity formula, and that molarity equals moles of solute divided by volume of solvent. Therefore, your volume of solvent, which is what we want to know, would be equal to this divided by that. Moles solute divided by molarity. Now, to solve this using the 4-step format, I'm going to first find my info. I knew that I had 3 molar solution and I had 27 grams of salt. And I'd have to convert that to moles in order to proceed. So I'd set it up on my bracket, 27.14 on the top left, and then I'm going to arrange my molar mass across from each other. I'm going to cancel like units. So those are going to cancel out. And then I multiply across, I get 27.14 grams NaCl over 58.45. I divide it, and I'm at 0.46 moles NaCl. And the next step is to find the formula. We just solved that on the previous slide. It's solvent equals moles solute divided by the molarity. Then I would substitute in. I'm going to substitute in this mass down, this moles here for the moles solute instead of the 27.14 grams, and divide that by 3. When I've divided that by 3, I will have solved my problem, and that's 0.155 liters of 3 molar solution NaCl. Here's an extra problem that comes from the text. You don't necessarily need to copy this problem, but it'll be a good review. You could try it on your own. So you want to produce a certain amount of a chemical, and you need at least a certain amount of another chemical, and you have a bunch of the second chemical in solution. So you need this amount of chemical. It's written twice in the problem. And you know this is your concentration, and this is how much you have. All right? This right here is you don't really need it to solve it. It's just part of the problem. And this number as well is not in there in the solution piece, but it's there. It is like if you have is 5 liters enough of it to get what you want. So we're going to solve this just like any other 4-step format. There's our amount of solute that we need. There's our molarity. And we want to know solvent, and this is how much we've got, a total of 5 liters, excuse me. Will that be enough? Now once again, the solute is in grams, as you can see right there. The solute is in grams. So I'm going to need to find the molar mass of potassium chromate. So I've got potassium, chromium, and oxygen. These are their atomic masses. That's how many I have. That's the products. I add those things up. I get 194.2 grams, and that's my molar mass. Now I'm going to convert that to moles so I can plug it in. I'm going to put it on the top left. All right, I'm going to arrange factors so that my like units are diagonal. I'm going to cancel out any units that are the same. All right, the next step is to multiply across. So 23.4 times 1 is 23.4. Divided by 194.2. is 0.121 moles potassium chromate. Now I'm ready to follow the next 3 steps. That's my formula. It's the same as last time. Solvent equals solute over molarity. I substitute in, I get X equals 0.121 mole, 0.120 moles potassium chromate divided by 6 molar. I'm going to solve. I'm going to divide this number by that number. It's going to be 0.02 liters of this solution, or 20 milliliters of that solution. And this is my source for the problem. I hope that's been helpful.